Welcome to the Daily Space Weather Smash Show here, coming at you from the Smash News Network, least busted name in news. Taking a look at the closest star and the associated weather cosmic ray report coming today. Also, don't forget to stay tuned for our meteorology segment. Sunspot number has dropped. Solar activity in general has dropped. And there's definitely some place to keep an eye on. It's the northwestern limb. So as we stated yesterday, likelihood of major flares really high in that portion of the closest star. And you can see some plasma instability there happening right at the end of the video. Some plasma splashing back down. Let's take a closer look at that. That is an ongoing situation. And it could lead to some significant coronal mass ejections. Let's go the rest of the way around the horn here. We've got some filaments in the southwestern limb, including that snaky shaped one there right in the earth-facing portion. Pretty quiet in the southeastern limb there. That new active region that rose is not a sunspot, at least not yet. And we do have at least one new named sunspot group that's recently risen in the northeast. So here's yesterday plus today in SDO intensity gram. We do have a little bit of growth of sunspots in the northern hemisphere here. We've got setting groups down here in the west. So there's a huge plasma bridge here suspended across the solar equator by those two huge sunspot groups. Don't be surprised to see M or even X-class flares in the next 24 to 48 hours. And we'll see a big dip in the sunspot number here coming as well, unless some new activity forms or rises. Here's your SDO colorized magnetogram. And before we see what's going on in other parts of Earth's space environment, let's take a look at Croissant Earth and see what volcanoes are erupting. Shivaluch, not sure if it's erupting or not. Volcanic ash not identifiable in satellite imagery. Sakurajima exploded. Unknown ash plume from Sakurajima. Please do not pole vault the caldera. Semaru exploding, flight level 140 over Semaru. And some ground deformation happening at the White Island volcano. Some subsidence on the floor, on the crater floor of the lake, as well as intermittent movement of the 1914 landslide. Popocatépetl exploding, flight level 210. It's a 21,000-foot ash plume over central Mexico. 16,000-foot ash plume over Fuego in Guatemala. As it explodes, Saab and Kaya were unable to detect if it's erupting. And same thing with Puyehu, Cordon, Calais in Argentina. No volcanic ash detected, yet it is on the list, so we report it. Next, seismicity over the past 24 hours has been pretty calm. There were some quakes over a 5 magnitude. That's the 90-day bar graph, and let's take a look at the list. So India had a quake at a 5.1 magnitude. That was at 13:42 Universal Time yesterday. Also, there was a 5.0 in the Molucca Sea. If you're wondering where that's located, right there, near the Philippines. Also, Indonesia had a 5.5, which I believe was a foreshock. So there's also a 5.1 in that same location and a 5.8. Once again, I'll say it again. Any earthquake can be a foreshock. There's a 5.3, looks like an aftershock. And also Nepal had a 5.6. That happened at 8:58 Universal Time this morning. And before we get back to space, take a moment to press like and subscribe. If you haven't visited our playlists, set yourself a note to click our end screen on our video today. We'll have one of our playlists showing up there. So make sure you check that out. Thanks to all of our YouTube subscribers for tolerating the pathetic putrid censorship on the platform for the past pushing 6 years, as we bring you the most detailed space weather and comprehensive imagery of the sun you'll find anywhere in the world. So here's 304 plus 211 angstroms. It's great at showing, well, the ionized helium, that's 304 angstroms. Great at showing active regions and coronal holes here. That's the 211 angstrom for coronal holes. And you can see the extended corona there as well. That's the pink portion. That's the 211 angstroms. That is ionized iron. And let's take another look at this little activity happening up here in the northwest. Very nice. And the 10.7 centimeter radio flux has dropped, by the way. Oh, here's another wavelength. There you go. And thanks for leaving a comment, One Audio. So there's some great depth shown with the 335 plus 171 angstroms. Again, radio flux has dropped to 189 solar flux units. So a precipitous drop here in solar activity, having reached new highs for solar cycle 25. There is the 1-year graph to put it in context. The black line is the 10.7 centimeter radio flux, and the red line is the sunspot number. Space Weather Enthusiast dashboard not forecasting any geomagnetic unrest or geomagnetic storms. I would say we're going to see an uptick in the solar wind density by the end of the day today, and an uptick in the solar wind speed and a downtick in the solar wind density by midday tomorrow. So look for that. Could be enough to cause a geomagnetic unrest or minor geomagnetic storm conditions caused by a coronal hole high-speed stream. So we'll see what happens. For some reason, NOAA not forecasting anything there. That's the Space Weather Enthusiast dashboard, if you're wondering. KP index currently at 1. It's geomagnetically calm conditions for sure. And here is Earth's magnetic moment for the past 4 hours. That's Earth's magnetic moment from space out to about 12 Earth diameters. The units scaled here are nanopascals, which is magnetohydrodynamic pressure. And here's Earth's magnetic moment from the ground. We are seeing some variations in the solar wind. It looks like some minor CME impacts, coronal mass ejections, have been occurring. Again, they are quite minor. That's Earth's magnetic moment from the ground for the past 4 hours in nanotesla magnetic flux density. Next, we'll move to the real-time solar wind. And you see these variations of about 50 kilometers per second for the solar wind speed. Also variations in the plasma temperature. And the density indicates some roiling incoming coronal mass ejections. They are very minor. Those have been happening for the past about 12 hours here. And again, those are not major CME impacts. That's what you call a glancing blow. No major signal in the magnetic field. Phi angle still shifting. Current conditions are only about 2.2 protons per cubic centimeter for the solar wind density. Solar wind speed 431 kilometers per second. So expect a big uptick in the solar wind density later in the day today. That'll be the shock front of the coronal hole high-speed stream. And then when you see that drop, you should see the speed come up. The telltale sign of a coronal hole high-speed stream. Tin Man 1057, good morning to you as well, and thanks for commenting. Next, more magnetic data here. These are the GOES 16 and GOES 18's magnetometers. Now keep in mind that these are at different locations, and this gives you insight as that M and that N, those are noon and midnight local time for the GOES 16. The blue N's and M's are the midnight noon local time for the GOES 18. And you can expect to see this kind of all over the place here in the coming days, as we are expecting a rather sharp coronal hole high-speed stream. If you haven't checked out the merch, you can find a link below the video to the Redbubble shop. If you do click the link, you'll find the products in order of best selling. Thanks to everybody who's picked up merch. Some of it's clever, some of it's inflammatory, some of it may be politically based. And I'm politically based in that I have no affiliation with a political party, nor do I ever expect to. So if you think I'm a political hack, think again. Today's featured product is Do Not Pole Vault the Caldera. We say it regularly. I can't believe I have to tell people this. It's a public service message brought to you at massive personal risk and expense by Smash staff and I, so give her a raise. Did you realize that Smash staff is a partner in the operation? And yeah, she makes a percentage of most of our most of our revenue that's generated from the creation of these videos, which is just this side of nothing, by the way. So pick up some merch, give Smash staff a raise. She desperately needs one. She is cut in to be our IT department, our website designer, and so on. Also our social media manager. Shout out to Smash staff for all of her hard work. We are also on Patreon. She's a partner in that as well. She gets a cut. So if you want to support the channel via Patreon, we are still on there, 3 different membership levels. And of course, the best way to support the channel is via Smash Team memberships. So if you're not familiar with the Smash Team, smashomash.com/Smash Team. It's our subscription services site. We launched it back in October of 2021 officially. And the best value is the annual paid-up subscription. So that is a gold membership for a whole year. It includes complimentary merch. It's almost like getting 4 months for free. Smashomash.com/Smash Team. It's got superior capabilities. We also send out email alerts, so you don't even have to be a paid member. There is a bronze membership level as well. There's a gold, there's a silver, there's a bronze, and there's a gold annual paid-up subscription level. Just click posts to see the latest posts that are visible for your level at smashomash.com/Smash Team. And let's get back to some magnetic data here. For some reason, it stopped playing. So here is your top view ecliptic plane field plot. We've got a South Pole current sheet rushing this way. I would say it'll be here by tomorrow, if not by later today. But it's certainly looking like it's imminent based on the activity that we see. And of course, that data right there, North Pole current sheet depicted there in green, South Pole current sheet depicted in red. So here's our line of sight field plot. Solar B field depicted here in blue. That's the field that goes through the magnet. It's sort of like a net field of the north and south. North and south depicted in green and red respectively. So yeah, most of the activity here in the northern hemisphere at the moment. And here is our line of sight coronal hole plot. We've got some South Pole oriented coronal holes rotating in here in the east. We can expect those to get a little more well-defined in the coming days. So these are North Pole oriented coronal holes. We can expect a stream from this one later today, the density wave. And then back here, these are South Pole oriented coronal holes. That's the last 24 hours from SDO and 211 angstroms, which brings us to sunspots. So we'll see the sunspot number dip today despite a new sunspot being named. We've got 3,201 right here. And that's the last group to not have a name, I think. So that's the current state of affairs. Likelihood of major solar flares incredibly high here with the setting of sunspots 3190. And this group here including 3191, 92, and 95. This area right here is where I expect to see an X-class flare, maybe multiple X-class flares. But we've already got some plasma instability happening there. And here is the last 24 hours from SDO continuum. Let's zoom in. That is not sufficient. There we go. And we've got plenty more to cover here, including energetic particles and solar flares. So no spikes in the proton flux. Those relativistic particles can show up as early as 20 minutes after a major solar flare. At the moment, nothing doing. And there's the GOES X-ray flux here. Only C-class intensifications here over the past 24 hours. Again, don't be surprised to see an M or X-class flare or even multiple X-class flares as those massive groups in the west set. We are seeing a little bit of an uptick there in flaring from those regions. And Let's take a brief moment to see what's going on overhead over Lehigh Valley, Pennsylvania. If you want to make your own star chart, try the skyandtelescope.org star chart. I like it. And if you're up before dawn, you may see Mercury rising ahead of the sun there. Here's what the horizon at the ecliptic looks like around Lehigh Valley, Pennsylvania. And high in the sky, you've got Spica. Here comes your solar system forecast. Here is where heavenly bodies are now. We'll advance at 1 week, as we've got a tiny sliver of a moon at the moment. Here's your 1 week forecast. So that's where things will be in 1 week. Keep in mind, this imagery is not to scale. And let's talk coronal mass ejections. There have been some. Are they earthly directed? Oh, wow. Wouldn't you like to know? In short, no. They're not earthly directed. At least they don't appear to be, unless I'm missing something. That's yesterday's imagery. That's 100 frames from yesterday, January 23rd. Here are today's frames. There's an additional 21 frames for today. And let's do a quick analysis here on Stereo A's coronagraph and Soho Lasco C3. So we've paused these images here at 2109 and 2130 because we see this little CME coming out of the north. Now, for you new viewers, from Stereo A's perspective, Earth would have to be off on this line. And from this perspective, Earth would be behind you, since Soho Lasco C3 is located at Lagrange 1. And we just paused it there to show that that is not an earthly directed coronal mass ejection. That is off to the north and to the west. So there is a coronal hole high-speed stream very close, about to be here at planet Earth. But besides that, it's a pretty clear environment out there. So here's the last 24 hours, featuring SDO 304 angstroms and the two Soho coronagraphs. We'll zoom out a little bit. And there's one more further zoomed out view. And next we'll talk filaments. And just let me reload that. For some reason it needed refreshing. It needed refreshing because reasons. So we still got lots of filaments here. Most of them are on the western portion. We do have some down here in the southeast as well. If you want to name filaments after living people, this one here is already named. That's the James Comer filament. It's loitering over there. It's just hanging out, and now it's becoming a filament from a prominence, as it's now sort of rising over the eastern limb. So lots of filaments here. Likelihood of additional coronal mass ejections nearly 100%, especially if we see a major flare from this area here, which I suspect we probably will. I think it's more likely than not. If you want to name filaments, you got to name them on Twitter. So follow us over there. Thanks to our Twitter followers. And thank you for tolerating the pathetic censorship, which actually continues on the social media platform, despite some people claiming that it's been fixed. Sure, all kinds of corruption's been exposed, but the censorship is still there. Shadow bans. We've got 18.6 thousand tweets, daily original content on our own web ring, and we've got 372 followers. So twitter.com/smashomash. We share all kinds of information you're only able to see on Twitter. So if you don't follow us there, you're missing out on some of the content, period. And let's get back to space here before we go to our bonus feature segment. So there's the last 24 hours in just ionized helium by itself. 304 angstroms, one of the classic wavelengths there. And here are the last about 2.5 hours. So again, you can see that plasma reorientation happening up there in the northwestern limb. And that is not done. Again, we've got at least 2 days of the possibility of major flares, as electrons suddenly decide, and protons suddenly decide to change their course based on the reallocation of all of that plasma. There's a magnetic tug-of-war going on there with gravity. Yeah, gravity. So those prominentiary features, those are a battle between gravity and magnetism. And you can see up here some gravity winning out as some of that plasma crashing back down. That is definitely not over, and let's move to bonus features. We don't want the video to be too lengthy. Satellite charging hazards are chillin'. No charging hazards at the moment. That's our satellite's community dashboard. The GOES electron flux here, just in a moderate range. We can expect to see a dip here later in the day when the coronal hole high-speed stream density wave shows up. So this forecast will likely be incorrect. We can expect this to be down here instead of up where it is, or at least by tomorrow we can expect to see lower electron flux. There's the one-year chart to put it in context. That's the relativistic electrons measured by the GOES 16 and GOES 18 from their geosynchronous orbits. That measurement is done at the F ionosphere layer using radiography. It's located at 300 kilometers of altitude, and here's the vibrational frequency. So that's the vibrational frequency in megahertz. We'll also show the anomalogram. And if you're not familiar with looking at this, well, I don't blame you. It's kind of weird looking. And if you don't know what you're looking at, it's the vibrational frequency of the F layer of the ionosphere. So here's the anomalogram. This is showing anomaly in megahertz from a 30-day median. And here come the latest images. There is 11:30 universal time ionogram and 11:30 universal time anomalygram. Let's look at the total electron content also, which is very anomalous, and we're expecting it to remain anomalous. It depicts the free electrons between your GPS satellite and your handset. That's a run of about 12,500 miles. And here's what's going on with the total electron content. Very anomalous here, huge bands of high electron contents, likely to cause very significant GPS errors all around the world. Also anomalies here with low electron contents over the Caribbean, portions of southern South America. So lots of oddities here, and you can expect these to continue with the arrival of a coronal hole high-speed stream. That's a basic, easy forecast for you. Let's let this play through one more time, because your GPS is likely to produce major errors as those huge red blobs are covering most of the planet's population. Perhaps turn on your Wi-Fi accuracy to increase the likelihood that you'll know where you are if you're using your GPS to navigate. So huge anomalies there. And let's close out the space weather portion with the latest intensitygram and latest, wait for it, colorized magnetogram. So again, this group down here, not a sunspot yet. This new group here, that's 31. I don't know what it is. I can't remember what it is. It is 3201. Yeah, 3201 will be the name of that new sunspot group. And it's only alpha class. At the moment, it only has one polarity umbra. There may be a trailing umbra there forming or showing itself. So anyway, here's the rock back. Of course, this group here is huge. It is beta gamma delta class. This group up here, certainly beta gamma class. And before we get to the meteorology segment, help us out with links. That is, clicks to links. In other words, click our links. If you haven't seen them, smashomash.com is the homepage. Join us on social media. You can find links to the Redbubble Shop, the Smash Team, Patreon, Instagram, and more. So make sure you follow us over there. Perhaps improve your health with a membership to the American Better Health Organization, otherwise known as SureMed. Would you like me to be your agent of record? Well, hit me up via the link there. I am a licensed Medicare insurance agent in 28 states. Smashomash.com, and welcome to the Neo-Renaissance. We built our own website because, well, we saw the writing on the wall with the pathetic censorship on certain, quote, social and, quote, media platforms. So we're doing a cosmic ray report here. Let's go around the planet. We're starting out very far south at DOMB Antarctica, and we've seen a downtick here over the past 30 days at DOMB Antarctica. What about DOMC Antarctica? Well, a similar downtick at DOMC. Let's go way up north to Finland. There is Oulu's cosmic ray station. That's the neutron monitor at Oulu, Finland. A small downtick there as well. So let's go much farther south now to Mexico City. And a small downtick at Mexico City for the past 30 days. Going up north and east to Athens, Greece. A downtick at Athens, Greece over the past 30 days. A modest downtick. And let's go way back up north to Apatity and Barentsburg to close out our cosmic ray report. So there is Apatity, a small downtick at Apatity over the past 30. And as far as Barentsburg goes, what do we have? A small downtick at Barentsburg as well. So no surprise there. Solar activity is known to be inversely proportional to cosmic ray flux. I'll leave it there and move to the meteorology segment. So we're being wave chasers now. Yeah, wave chasers. We're looking for the planet's largest wave. So what do we have in the North Pacific? We've got some 28-footers in the North Pacific. And here in the North Sea, north of Sweden, we've got some 29-footers. Are those the biggest waves in the world? Well, the answer is no. The biggest waves in the world are in the Southern Ocean. At least 30-footers down there. Yes, wave chasing. It is a hobby that I will take up in earnest at a later time. We'll keep you posted on the YouTube channel. All right, so let's look at surface winds here as we do meteorology. Here is the surface wind scenario for the eastern world. Yeah, the most populous portion of the planet. Geez, we wish we had some audience in this area, as there are over 2 billion people within that circle. Here are the jet streams of the eastern world. Yeah, space weather. It pertains to everybody on the planet. Also, Elon Musk should be watching the videos, but instead he continues the shadow bans on Twitter. A ridiculous and pathetic practice. Taking over a crime syndicate and maintaining the crimes is probably unwise. What do you think? Let us know in the comments. Here are the jet streams of the western world. Here are the surface winds of this side of the planet. It's windy in the western Atlantic. Also strong onshore wind there at Galveston. Here are the surface winds of the central world. Yeah, Europe, Africa, and the Middle East. Shout out to our viewers from all around the planet. There are the jet streams to close out our 3-stage wind coverage. And let's see what's going on in terms of clouds and fog over the Americas. So this is our 3.9 nanometer infrared radiation satellite. It'll show you clouds and fog even though the sun's barely rising over the Atlantic coast of the 2 American continents. There's a situation. Strong storms here forming over Texas. So here is your weather.gov map. If your location is lit, click your location. There are a few too many counties for us to cover there, but lots of winter storm warnings there across the country. We've scrolled down to show you the key to give you some idea of what's going on. Some great surf in Hawaii, it looks like. Anyway, again, if your location's lit, click your location on weather.gov. And let's take a look at some forecasts. So here's our pressure and precipitation forecast. Again, that low is going to intensify as it approaches the Louisiana border produce some quite strong storms here. And there will be plenty of snow there. Let's take a look at the total accumulated precipitation first, since there will be some heavy rains in East Texas and Louisiana. Looks like over 4 inches forecasted there for portions of Louisiana. That is your total accumulated precipitation based on the same model which we showed you earlier, the GFS 72-hour forecast. We'll also show the total accumulated snow depth change forecast, the total positive snow depth change. That is in inches also. Some decently heavy snow there coming to the Texas stovepipe. Most of Oklahoma expecting to be coated by the GFS model. Also some rather heavy snow there for Arkansas. Most of Missouri. Well, anyway, you see the map. That is a 72-hour GFS positive snow depth change forecast in inches. And we'll also show the Euro forecast and the differences. So here's our windy.com map. We're going to show the European forecast. That's the next 12 hours. Expect some significant snowfall there in New Mexico, Texas, and Oklahoma. Next 24 hours, Arkansas can expect some significant snow. So that's new snow. And there's the next 3 days based on the GFS model. So here's the Euro model, and you can see it's a little bit different there, but they are starting to converge. Again, there's the Euro model. There's the GFS model. The Euro model has the storm shifted a little bit to the north. Again, GFS. There's the Euro. Windy.com. Check it out. They got a free mobile app. It will spy on you in order to account for its freeness. It's just a weather app, folks. It's quite useful, really. Anyway, here's our NASA GOES lightning mapper, and a little bit of lightning there over Texas in the past about 10 hours. It has subsided, it looks like. And do we have any terrestrial strikes? It looks like we may. What do we got? We got some strikes here between Lufkin and Houston, near Livingston, Texas. There's thunder rolling in, I think. Anyway, some minor thunder showers happening there. That is a real-time lightning map, we hope, from lightningmaps.org. And here's our U.S. Doppler. And we'll focus on the lower 48. Here is the shortwave radiation for the lower 48. And here's the water vapor map. That should give you some additional insight here. We've got some cold air dipping down, dipping down. And that's providing a slight impulse here as it collides. It's wanting to drive the weather to the east. Why? Because of this high pressure. So this dry air is effectively a high pressure zone. So it's creating a pressure gradient as well as a bit of a boundary there, because dry air is more massive than moist air because of the molecular mass of N2 versus H2O. So here's your recap. Doppler radar. Clouds and fog. And there is water vapor. That shows all the water vapor. And that is where we'll close things out. So thanks for tuning into the Smash News Network, least busted name in news. If you're thinking that might be a dig on CNN, it absolutely is. CNN, the most busted name in news. SNN, the least busted name in news, as we cite facts. And I sign off. In the meantime, may that solar wind be at your back. Opinions expressed in this video are not necessarily the opinions of Smash News Network, least busted name in news. Facts stated in this video suppressed for your convenience by big tech criminal organizations to improve your online experience.